Hey class, this is the first 2 pages of the review. I just want to give you some hints as to make this a little bit easier for you, like where to find the information, what to do. So take a look at the vocab here. I'm just looking for a very simple explanation. Something like absolute zero, you would say something like lowest possible temperature. Okay, something, accuracy, how close to the true value, Celsius, temperature scale, where boiling point is 100 degrees and freezing point of water is 0. So all of these terms you see that we have used them all this past unit. So I just want to point to the second matter that's listed here. You only have to define matter one time. So let's move on from that. There's some other ones. Again, all of this stuff that we've talked about. So let's get into the actual problems. Now, notice this is the first column. Once you flip the page over, and it says convert the following measurements. And this is our metric to metric conversion. So for the first one, for our metric to metric conversion, if you remember how we did that, this is going from centimeters to meters. And because we have one just like the base unit of meters here, and centi is the prefix. Remember how we do this. We're going to take whatever the exponent is for centi as the prefix. So centi is right here. That's a -2. So I take -2 minus, and then whatever the prefix is for meters, but there is no prefix. If you remember, meters, liters, grams, seconds, all of that stuff happens right here. At the times 10, this right here is times 10 to the 0. So we use the 0. So -2 minus 0 equals a -2. If it's negative, that means we're jumping 2 places to the left. If we were to get a positive answer to this, we would jump 2 places to the right. So what does 2 places to the left look like? I go 1, 2 places, I put the decimal point and fill in with a 0, like that. So my answer to the first part here is 0.01254, and that's in meters. So 0.01524, and 254, there. And that's in meters. All right, let's take another look at another problem here. Do the next one. Next one is, let's do one that's a little bit unusual. How about we do this one here where it goes to microliters to liters. So that's 78903, and that's microliters to liters. Micro is right here. It looks like that symbol there, and that's a -6. So -6 minus liters. Liters is right here at times 10 to the 0. So again, we're going to move the decimal place 6 places to the left, like that. And my decimal point starts off here behind a 3. I jump 1, 2, 3, 4, 5, 6. Decimal point and fill in with a 0. So that means I got 0.078903 liters, just like that. That's how we do all of them. We subtract, okay? One more example, how about this one with kilopascals to pascals? So 4.573 kilopascals to pascals. Pascals is right here, PA. That's another one. So kilo is a +3 because of this right here, kilo, +3. I'm going to subtract pascals. Pascals is a 0. I have a +3, which means I'm going to move the decimal point 1, 2, 3 places to the right. So that means 4.573 pascals. Okay, positive goes to the right, negative goes to the left. We simply subtract the two, the exponents that we have. And many times you will have ones that line up with these, which is 10 to the 0. All right, good luck with that. Let's move on to density. How do we do density? We got density over 1 equals mass over volume. So we multiply, crisscross the multiply. if we have 20 grams of each of the following acids are needed, find the volume. Okay, so if we're looking for volume here, like this, plug in what we have for the first one here. Notice that each one of these is 20 grams. What is grams? Is grams a density, a mass, or a volume? And 20 is a mass. So volume is what we're looking for. Density is 2.64 grams per milliliter, like this, over 1. So 1 times 20 gives us 20 grams, excuse me, and 2.64, equals 2.164 grams per milliliter, and then that's times V, like that. So we divide both sides by 2.164 grams per milliliter, 2.164 grams per milliliter. Sorry about that, I got confused. I got out my calculator. Calculator is 20 divided by 2.164, and my answer then for volume is 9.24. This one has 1, 2, 3 significant figures. This one has 1, 2, 3, 4. So we round off to 3 places. Okay, so if I can show you what I got in my calculator, this answer is not correct. It's got too many places, 1, 2, 3. I check here to see if it's 5 or higher, and it's not, so this would be milliliters. That's how each one of these B and C work. Excuse me. One. Sorry about that. Now, calculate the mass of the aluminum block if the volume is 26 or 25. Excuse me. Okay. Mass is what we're looking for. That means that we need density. What is density? Density is on table S. You're looking for aluminum. It should be number 13. It has a density of 2.70. That's grams per cubic centimeter. So what do I do for this? Density over 1 equals mass over volume, like this. So density is 2.7 grams per cubic centimeter over 1. Mass is what we're looking for, and the volume is 25.6 cubic centimeters, like this. So I multiply these two, and I get mass equals, and then 2.70 times 25.6, like that. What does that equal? And what I get then is 69.12, and that's in grams, because that's mass. I have 1, 2, 3, 1, 2, 3, 3 places, 1, 2, 3. I check to see if that's 5 or higher. 69.1 grams. There you go. That's how you do those density problems. All right, good luck. Here's the next page is up next.